have picked up the problems, numerical problems from your this moving coil galvanometer topic, and these are the questions which I have selected. These are actually from your previous year's exams or from some competitive exams, etc. So I have picked up some 5 questions from here, galvanometer. Then, if time permits, I'll take up few other problems from other topics as well. Okay. So, see, before I go to directly the problem, numerical problem, I'd like to remind you few facts on this moving coil galvanometer. First thing is, see, moving coil galvanometer, like you have a coil over there, and you have a magnetic torque on the coil and restoring torque as well by the spring. So restoring torque by the spring was this, and the magnetic torque was NIAB, right? This was the magnetic torque, because magnetic field and your magnetic moment, these are perpendicular to each other. So that's why there is no sin theta term there. Okay. So this is M, this is B. So MB. Look, this phi can be written then. This is NIAB by K. And see, if I just eliminate this I from here, suppose I'll keep in the bracket only a I can be outside. So this factor is constant for a given galvanometer. Okay. So this is one thing. And look, current sensitivity. So this is actually angular deflection of the point, and see, my galvanometer is something like this. There will be a neutral point, zero line over there, and like your pointer will be somewhere here. Okay, and the zero line, when there is no current to the coil, and when there is a current, it can deflect from the zero line either right hand side. Okay, and similarly it can deflect the left hand side also. So these are called deviations. These deviations we have obtained from the calibration. See, if I say this is now here for some current, this is phi. This is called angular deflection. Okay, and I can read. So this from this division of the scale. This is actually scale division. This is a part of scale, and I can directly read from here how much current or how much voltage is. Alright. Actually, like this is called torsional. See, this is called torsional constant. Actually, any wire you take, then if you just fix this wire at any wire there in the ceiling, and then you tie something over here in this wire, thin wire, and then rotate it. Like what will happen? There will be a twist actually. Twist. See, some part. This part will be as it is, but this part will not twisting. So there will be angular deviation. Okay, angular deviation, or I can say, and this is called actually the modular will be getting the torsional, this is called, I think, rigidity modulus. Eta, it is expressed by eta, rigidity modulus. I hope you people have learned in your 11th standard. Okay. So from there I am getting this thing. Okay. All right. So this R is directly related to this linear scale. Okay. So there we see this R is actually directly proportional to R. I can just have a calibration sheet. Calibration sheet is for a given galvanometer for how much current, how much calibration it goes, deflects. So that can be given, that can be obtained by calibration. According to that, the scale will be given. Okay. So now from here, if I want to know what is current sensitivity of the galvanometer, then you have to find out this angular deflection divided by angular deflection per unit current. This is called angular deflection per unit current. And, right? So sometimes this current sensitivity, or in case of voltage sensitivity, it is pi by this. So angular deflection per unit voltage. So this also can be given. This is called voltage sensitivity, and this is called current sensitivity. Okay. So sometimes this current or voltage sensitivity will be given in terms of division also. Rather than giving you angular deflection by some angle, degree or something like that, it can be given as a division, suppose 50 divisions. 50 divisions like that. 50 divisions per milliampere, kind of that. Okay, it can be given like that. This is also current sensitivity, or if it is millivolt or volt, then it is actually voltage sensitivity. So instead of giving angular deflection, sometimes divisions also you can get. Okay, divisions per unit current or per unit voltage. So this is about this galvanometer. Now let us take up few uh, problems, numerical problems. So look, I will show you in my PDF file over here. So this question is, look, I hope you people are able to read my handwriting. Otherwise, also I am reading anyway. So the moving coil galvanometer has an effective area. Effective area is given 5 into 10 to the power minus 2 meter square. It's suspended in a magnetic field of 2 into 10 to the power minus 2 omega per meter square. If the torsional constant of the suspended fiber is given, this is Newton per degree. Okay, Newton meter per degree. So this is a torque. Okay, so phi k into phi is torque, so k phi. So this is the unit of the k. So what I'll do, I'll just write down the information one by one, what are given, and then what is the question here? What we have to find out? Then find its current sensitivity in degree per microampere. Okay, that means you have to find out phi by r. Let us see that how we can find out. So what is given? I'll write the parameters what are given here. The effective area is given, that means A is given. What is that? 5 into 10 to the power minus 2 meter square. And then magnetic field. See, this B is given, and the unit is actually this. This is omega per meter square. Here Tesla is not given. See, I can express this phi. Actually, phi means magnetic flux is equal to B into A. B into A means
Sir, what
this
is
magnetic
WB?
density. O bar. However, this is
Okay.
unit of magnetic flux. I think we have not studied yet. We'll study that magnetic flux. In the next chapter, we'll study that magnetic flux. Okay, just like your electric flux means field area, right? Electric flux field area, and similarly, this B into A, magnetic field into area, is called magnetic flux. That is also defined as phi. You don't get confused with this phi. Okay, phi here we are discussing for moving coil galvanometer. That is angular deflection, but this is called magnetic flux. Okay, magnetic flux also defined as phi, which is B into A. So see the unit I can, if I know the unit of this, I can find out what is the unit of B. So the unit of this is actually OR. Okay, OR, and it is written as WB. And this is area, so it will be meter square. OR and meter square. Okay, so this side this unit is. So I also was thinking to discuss this unit. Okay, so all right. So you have understood, I know. This is OR per meter square. Now, actually, flux is always, whether it is electric or magnetic or something else, flux is always like somewhat conventionally denoted by phi. Okay, anyway, so magnetic field is given, then total constant K is given. What is that? This is 4 into 10 power minus 9 into meter degree inverse, that means per degree. Okay. So what you have to find out? You have to find out the current sensitivity, that means phi by r. You have to find out this. Okay. So can you people try? I'll just give 2 minutes. Everyone can tell me whether they are able to get the answer or not. What about Priyadashini? Are you trying? Samita, Nikhil, Deepa, are you trying? Uh, yeah. Okay, I can help you just by showing the previous slide. Maybe then you can get some idea. Look from here. Look from here. So look, this phi by I is the current sensitivity. This will be actually equal to N A B by K. Okay. So all the things are given. Okay. So here the number of turns is not given. Then what should I take? This I will take as a 1. Okay. Then A B by K. A B by K. If you do this, you'll be able to get uh, this current sensitivity. Let us put all the values in same unit. So all are in SI unit only. So I have to just multiply this. And divided by this is K. Okay, sorry, this is 9. Yeah. So if you do that, this is actually 2, this will be 2.5. Okay. So I just take this is 2.5 into this 4 minus this will go. This is, so I think this is uh this is your meter this. Okay. So this is 5 pi by. So if you write this as 10 to the power 6, okay, 10 to the power 6. So you will get this is degree per microampere as this, okay. If you, so your value will be pi by I as 0.25 microampere. Sorry, degree per degree. This is degree per microampere. Okay. All right. Anyone has any doubt or something? Can ask me. If somebody has some doubt. Generally, this has a unit of per ampere. So per ampere means, okay, so we might be having a doubt over here. Okay, I'll just go to the next slide. So what we have got, I by I is equal to, we have got 0.25 into 10 to the 6. Okay, so what is this unit? Actually, degree per ampere. Okay, all right, degree per ampere. So look, when I write 1 ampere, okay, 1 ampere, I can write as 10 to the power 6 microampere with 1 ampere, okay, 10 to the 6 microampere with. So part, see, if I write what is per ampere then? What is per ampere? That means 1 ampere is 10 to the power minus, sorry, 1 microampere is this one, 10 to the power minus 6 ampere, okay. So look here, per ampere means it is 10 to the power minus 6 ampere, okay. Per ampere means 10 to the power minus 6 ampere. So that's why this can be written as 0. This microampere. I hope you agree with me and you have understood this. If not, please ask me. 10 to the 6 per ampere means 10 to the minus 6 ampere. Okay, that's what I want. So from there you can write this as degree will be always there, degree per microampere. Okay, this is the answer. So what is the final answer? You have got I by I current sensitivity 125 into 10 to the power, sorry, 10 to the power 6. I am not right again. Since we have got this degree and this is per microampere. Okay, so this is the question. As the question was written that find its current sensitivity in degree per microampere. That is what they wanted. Okay, I just go to the second question. I just go to the second question. Second question also similar to this one, sensitivity division etc. So the previous one was like directly the got from there. Now look here. The second question is a galvanometer needs, so the galvanometer needs in writing I have used the S. So a galvanometer needs 50 millivolt for a full scale deflection of 50 divisions. Okay, find its voltage sensitivity. What must be its resistance if its current sensitivity is this much? I will write the information. I will repeat the question. There is the galvanometer. Okay, I'll just draw there and then you can to appreciate it. So the question is here. There is a galvanometer. There is a galvanometer like this, which is 0, and you have resistance like this. So here also resistance like this. Both sides. So neutral point is this one. when there is no current flowing in the galvanometer. Okay, this is the thing. Now, see, so full scale reflection, as I said, full scale reflection means it goes up to here. Okay, the last point of the scale. Okay, last divisions of the scale, that is full scale reflection, like this. It is full scale reflection. Reflection means what? It will come up to here and then go back to here. Okay, this is full scale reflection. So here it is given galvanometer, you have 50 divisions. Okay, that is what the question is. So 50 divisions are there. That means from here to here, there are 50 divisions. Okay. Similarly, from here to here, there will be 50 divisions. This is positive side suppose, and this is negative side. Okay, negative side. 50 divisions are there. Okay, and see, if I want to have full scale reflection. That means all 50 divisions will come and then go back to zero. If the current, sorry, if the voltage in this is this much millivolt, okay, 50 millivolt. That much voltage is needed for full scale reflection. Okay, then these are the information given. You have to find out voltage sensitivity of the galvanometer. Voltage sensitivity of the galvanometer. I think I'll send out the questions to madam. Okay, if you can try out again, practice at home again after this class. Okay, so find out the voltage sensitivity of the galvanometer. So this is the first question. Okay, this is the first question. Okay, let us try to solve this part first. Then there is another question as well. So as I said, voltage sensitivity, we have learned voltage sensitivity means, so I'll write voltage sensitivity Vs, which is actually the angular deflection by voltage. Or if it is divisions, then total number of divisions divided by the voltage needed for voltage. This is actually total number of divisions and voltage needed for full scale reflection. Then you will get division per voltage, right? So that's what full scale reflection. So this will give you the sensitivity. So if I want to calculate that, let us see how we get. So division number of divisions is 50 and voltage required is 50 millivolt. This is the watt. So what is the voltage sensitivity? The voltage sensitivity will be 650 goes up. Then it will be actually this will be 10 to the power 3 divisions per volt. Okay, this is per volt. Okay, so
Sir, not right. 1 into 10
any
power
doubt?
3.
I think someone is sorry.
Sir, not right.
Come
1
again,
into.
who is speaking? 1 into 10 to the power 3. Okay,
Yes, sir.
so these are same actually. These are same. If you write 1 into 10 to the power 3 and if you write directly 10 to the power 3, both are same. That's why I am writing like this. Okay, you can write 1 into 10 to the power 3. Meaning is same. Okay, that's the reason. Okay, so I hope you guys are understanding what is voltage sensitivity. What about Nikhil? Are you understanding, Nikhil? Okay, hope he is listening. Okay, so then the second part of this question, I just wrap some things over there. Second part of the question is that voltage sensitivity, current sensitivity is also given. If the current sensitivity is also given, then what is the value of the resistance in the galvanometer? Understand? What is the value of the resistance in the galvanometer? So see, any galvanometer, galvanometer always symbolically galvanometer written as like this. So this is galvanometer. This is the resistance associated with this. Okay, this is how capacitance is written anytime. So here the scale and everything will be there like this. Okay, so that is the always associated resistance with that. So you have to find out the resistance of the galvanometer if suppose the current sensitivity is also given. The current sensitivity is given here 1 division per microampere. So this is what given. Okay, 1 division per microampere. All right. So this is given. So if you want to calculate what is resistance Rg, you have to just go back. So voltage sensitivity we know by sorry I by V or division per voltage by volt. In this case, we have got that actually 10 to the power 3 division per volt. Okay, so that we have got already here. So like we have equation I is equal to N A B by K into I. So what is the voltage sensitivity and current sensitivity from this equation? If you just try out, if you just remember from your textbook what you know, what is voltage sensitivity, what is current sensitivity. Voltage sensitivity is voltage sensitivity as right, voltage sensitivity will be this N A B by K. This is common. This is by K. So this will give you N A B divided by K and whole into 1 by R. That means I by B is equal to R. Okay. So I by B is equal to R. So if you want to calculate this R, what you have to find out? So what you have to do? See, this is actually current sensitivity is only this part. This part is current sensitivity. So I can write this voltage sensitivity as, see, the current sensitivity. This is called current sensitivity. If I write current sensitivity IS into 1 by R. Because see, this part is, see, pi by R if I write here. So you get NAB by K. This part is current sensitivity divided by R. So this is if I write voltage sensitivity, okay, VS. So what I get as R is current sensitivity by voltage. Okay, are you still understanding and do you agree with me, all of you? So we get the resistance of the galvanometer equals just take the ratio of current sensitivity to the voltage sensitivity. Okay. Now let us write those values here and calculate that. So R will be R of the galvanometer, resistance of the galvanometer Rg I will write. This will be current sensitivity divided by voltage sensitivity. So current sensitivity is given already, right? So 1 division per microampere. And the voltage sensitivity was given this much. Okay, so yeah, volt will come, volt and this is 10 to the power 3, 5 volt. So I write, so microampere I can write as 10 to the minus 6 ampere, right? Okay. So this is voltage. One I can write 1 volt. This, as you said. So see this volt and ampere that will give you that. This is just division again. So division goes up. So the volt per ampere will be the resistance. So you will get actually 10 to the 6 divided by 10 to the 3. So this will give you ohm, and you will get 10 to the 3 ohm. Okay, how much you get? You get 10 to the 3 ohm. Okay, do you understand this problem? Like how I have written one division for microampere. So instead of writing microampere, I am writing ampere in terms of ampere. Okay, so that is what I have done here. So it will go numerator 10 to the 6, and the denominator will be 10 to the 3 as it is. Okay, so finally what you get is 3 ohm. Okay, 1000. So this is how this question goes. Okay, now, so now I just go to another level of the question. So, so this is with sensitivity part. If you are having such type of question, you will be able to, I think, solve it now. You can try many other problems like this, okay, with the sensitivity. Now, what I'll do, I just go to the. So I hope you people will be able to solve the other questions what I have given here. I'll just send this to Guna madam so that she will circulate this to people and you can practice those things. Now I just go to, so this third question is also similar type of question, okay, related to sensitivity. Okay, let us take this question as well. So this question is saying that uh, there is a moving coil galvanometer which is the following particles are given. So number of turns N is given, the area of the loop is given, coil is given, magnetic field is given, the resistance of the coil also is given. So what I have to find out, indicate a simple way to increase the current sensitivity of the meter by with 5%. It is not easy to change A or B. That means area of the loop and magnetic field cannot be changed. So in that case, what you would do to change the sensitivity, current sensitivity of the galvanometer. So I'll just write down the parameters given over here. So, parameters are given. Suppose A is equal to 24. This is the number of turns in the coil. Area is given as 20 into 10 power 3 10 to power minus 3 meter square. Okay, and then B is also given, that is given as 0.20 Tesla. So this is given as Tesla. Okay, C for Tesla. Okay, and the coil resistance of the coil is also given as this 14 ohm. So what you have to find out, what you have to do is you have to find out there is current sensitivity. Okay. So in this case, current sensitivity will be there. So you have to increase that current sensitivity to some I1. Okay. And if you take this on the algorithm maybe IS and this as IS current, this is the new current sensitivity. So and then IS plan. So you have to increase this. That means like the IS plan by IS has to be 20%. Okay, 25%. So IS plan will be 25% of IS. Okay. I'm sorry. This is you have to increase by 25%. You have to increase by 20%. That means yeah, you have to take the ratio so that it get yeah. I think it is all right. What I have written is all right. So what you have to do in this case? How do you increase? Not increase by increase to this person. Okay. So how to do that? So look here, as we have discussed already in the previous uh, problem. This phi by I is equal to N A B by K. So this is current sensitivity. See, in the problem it is given that this cannot be changed and K is always constant. So what can be changed is a number of times. Okay. So now let us see. I write this N as N1 and others are same. Okay. Others are same. And in this case, it was N A B by K. If I take the ratio of these two, what I get N1 prime. N1 prime A B by K divided by again N A B by K. So this A B by K, this will be cancelling each other, and this sensitivity is 25%. Okay. So if I go here, see N1 prime will be this into 25. Okay. So look, if I write this N was 24 divided by 2500, this will be your 4, this will be 6. Okay, so you have to increase by 25% to say, then your this you have to actually you have to increase your turn number of turns, okay, number of turns by this 6. Okay, if you increase by 25%, you have to increase. So I think this is n by n1 this number. So you have to n by n1 is 25%. So like you have to get this new turn number of turns. Actually, question was I think I yes new is actually is plus 25%. This was the s plus not is for x. Okay. So into I. This one. So your a actually will be if I write this as right, and so this will be in one is in into this one. So 1 plus 25%. 25% of this. So that means this is actually 24 given already. So 1 plus this will be 1 by 25. So 100 this is 1 by 4 into RS. Okay. So this is 5 by 4. Look here. So this is 24 by 4 into 5 here. This will be so if your current number of times will be actually number of times it was actually increased by not IS into 25%. It is IS plus 25% of okay. Then you take the ratio that you get. Shall I repeat or you have understood? This people understood. Have you people understood this? Or I will repeat once again. Do you understand? Nikhil? You people have to say something, otherwise I don't understand what I am doing here. Hello, previously, am I audible? Am I audible to you? Okay, so I'll repeat it. I don't know whether you were confused or you are all right. So in this case, see what I have taken here, this IS by IS by IS is 25%. It is not correct. So you have to increase according to the question. You have to increase by. So you have to increase to this. Increase to this. So IS time will be IS plus 25% of IS. This much. Okay. So for that, how much number of terms you need? If you get this ratio, you will get this gain on. So like you have to multiply this n one is equal to n into this multiplication. Okay, that is what I have done here. So that's how you get the new number of terms. You have to include the number of terms in the coil. How many? Equally equal to 30 terms you have to get. So that your sensitivity will be increased by 2. Okay. So this was the question. This question has another part actually. So another part of the question is if in doing the resistance, sorry, doing so, that means I have increased my current sensitivity by 25%, and in that case, what we have done, number of times we have taken 30, okay, where earlier it was 24. All right. So question is in doing so, that means while doing this thing, the resistance of the coil increases. The resistance of the coil increases to this much. Okay. Earlier the resistance was how much? Suppose I write this is R, this is R1. So earlier was 14, this is now.
Sir, R1 is
Sorry? You want to know what is R? R is the resistance of the coil. R is the resistance of the coil. And R1 is the resistance of the coil in the see when I am increasing the sensitivity, my number of turns has increased to 30. Earlier it was 24. So as you increase the length of the coil, length of the coil, then your resistance also will increase.
நீங்க அவங்க வீடியோ பார்த்துட்டு இருக்கீங்களா?
Nikhil, can you mute yourself?
நீங்க அவங்க வீடியோ பண்ண ஆரம்பிச்சிட்டீங்க. ரா ஏஜென்ட் ஃபோன் போயிடும் அடுத்த நாள். From பாயாசம் யூடியூப் பாயாசம். ப்ரோ பேர் என்ன? யூடியூப் நந்துவா? நந்து ஐடி.
Nikhil, can you
4.5
mute
லட்சம்
yourself
சப்ஸ்கிரைபர் வந்திருக்கு.
because
யார் யாரும் போல பிராங்க் பண்றோம் போல. நந்து கேமிங் ஐடி ஆரம்பிச்சிருக்கேன். 5K அவரா? 5K வச்சிருக்காரு அவரா? ஒரு கோடி வந்திருக்கே, ஏதோ கோடி. பாடு
Okay, so now I have to say that what is the voltage sensitivity whether it is less or more compared to the original one. So let us see what is voltage sensitivity. Voltage sensitivity was pi by V. So this was actually this A V divided by K into 1 by R. So this was suppose original one. And now the sensitivity I have to find out CS suppose, and this is DS bar. So this is again I by V. Look there is 1 V by K. Okay. So this is actually R1 now. Okay, if I take the ratio of this, let us see CS prime by PS. So this stuff look this base for A1 will be there. K, AB, this will be cancelled from both of them. A1 by A, this is again. Now this will be R1 by R. Okay. So look, I just put the value. So A1 is 30 divided by 4. And this is actually R1 is 21 divided by 40. So if I do little bit of simplification, 6 5, 6, 4. Okay, so we look at another 3, 2. So you get actually 15 by 8. So this is greater than 1. So now your sensitivity, you have to check how much it is, whether it is increased or not. Okay, so this is how you can find out this. Okay,
சரியான்ட்டு 2 ஹெச் சைடுல நிக்காது ப்ரோ கோபுரா ப்ரோ ஸ்ட்ரைட்டா இருக்கானுங்க எங்களுக்கு ஸ்ட்ரைட் ப்ரோ அந்த வீட்மேன் நிஞ்சா ப்ரோ வீட்மேன் ஒரு பாட்டு ப்ரோ அது போய் அடிச்சிட்டோம் ப்ரோ அவ்வளவுதான் எங்களை ரஷ் பண்ணிட்டானுங்க
This too much disturbing. I don't know how to stop this.
நைஸ் ப்ரோ நிஞ்சா ப்ரோ வேற
Okay, I'll take up one more question. Okay, about this type also this sensitivity from this kind of question. You can, I think this kind of question you can answer now. I'll just go to the other type of question. That when see you are asked to convert a galvanometer to ammeter, or you will be asked to convert a
ரிவை முக்கியம்
ammeter. How to do that? Okay. I'll show you one that question. So look here. The first one. This is I think this is from NCERT textbook or something. Look here. This question is a galvanometer with a coil of resistance. So full scale deflection for a current of this one 2.5 milliampere. How will we convert the galvanometer into an ammeter of range this much and voltmeter of range this much? Okay, so ammeter has a range. You have to convert this galvanometer into an ammeter which has a maximum range of 7.5 ampere current. You can read from 0 to 7.5 ampere. Okay? And the voltmeter can read 10 volts. Okay. Okay, so I just write that. I just write here this information. Okay. See, there is a galvanometer. So this symbolic galvanometer will be written like this. This is the galvanometer K. This RG resistance associated with K. So few things are given. So this RG is given. Okay, RG is given. What is given? RG is given as 12 ohm. Okay, 12 ohm. And then One more thing is given. See, it is given that when galvanometer shows physical reflection.
என்னப்பா கேட்டா எப்ப பாருங்க
The current flow, the galvanometer, that is the maximum allowable current. Okay, so the physical reflection, because that if you increase the current, the galvanometer may get damaged. Okay, so that is the maximum allowable current you can use. So we have to question was when the galvanometer shows physical reflection, then the current of the galvanometer is
எவ்வளவு சொன்னீங்க
0.5 milliampere.
இப்போ
So this is the allowable current. This is the maximum
பண்ணுங்க
allowable current.
அக்கா
Maximum allowable current to or allowed current to galvanometer. Galvanometer. Okay. Okay, this is the thing. So now with this information, what you have to find out, you have to convert this galvanometer into an ammeter. So first question is let's convert galvanometer to an ammeter. Okay, galvanometer G for galvanometer to ammeter. An ammeter has a range 0 to 7.5 ampere. Okay, that means it can read maximum current of this. Okay. Okay. So I hope you remember that if you want to convert an galvanometer to an ammeter, you have to use a shunt resistance. Suppose this and resistance are shunt means very small resistance, and you have to find out what is the resistance for that. Okay. So the question was how do you convert that? How do you convert that? Okay. How do you convert? So that was the question. How do you convert? So that means you have to connect a small resistance. Okay. Small resistance in parallel with the galvanometer. So and see here things are given, the maximum RG is given, maximum allowed current is also given. So and the range of the galvanometer ammeter is given. Range of the ammeter means the main current in the main. Okay, current in the main is this one. Okay, current in the main is this one. So the suppose current in main is R, and the current through the galvanometer is Ig, and current through the shunt is Is. Okay, Is. So Is is equal to actually I minus Ig. Is equal to I minus Ig. Alright. And what if I have the main? See, this is the maximum range. I is the maximum range of the ammeter. Okay, this is that. So now I hope you people will be able to find out what is RS. So that is what you have to say. That you have to connect some resistance to the galvanometer, and you have to find out the value of that resistance, not resistance. Okay. So I can write this simple equation. See, I can write a simple equation. Okay. The voltage across both is RS and RG will be same. So what I can write is IG RG equal to IS RS. Okay. So RS you have to find. So RS means IG RG, which are both given, and IS I can find out from there. So what is IS? This is your 7.5. This is ampere, and this is your Ig is 2.5 into 10 to the minus 3 ampere. Okay, so this much is the current. So we just put all these things. Okay, so what you get here is the RS is equal to Ig RG divided by this is IS. Okay. So what is IG? IG is 2.5 minus 3. What is RG? 12 ohm. And what is IS again? This is 7.5 minus 2.5 into 10 minus 3. Okay. If you just calculate this, you'll get the value. So you can do that and find out. And you know what you get is actually 4 into 10 to the power minus 3 ohm. Okay. That means 4 milliohm resistance you have to connect with this. Okay. 4 milliohm. Okay. 4 milliohm. So this is one part of the question. And the other part of the question was the same information. Okay. I just did graph some of the things. With the same information, we have to convert this galvanometer. You have to convert this galvanometer into a voltmeter which has a range of 0 to 10 volt. Okay, 0 to 10 volt. So how to do that? See, when we convert a galvanometer into a voltmeter, a galvanometer to a voltmeter, voltmeter. So what we need to do? We need to, this is galvanometer, this is RC resistance, galvanometer. So we need to actually connect a very high resistance in a series. Okay, in a series of this galvanometer. Solve that. So voltmeter has a range 0 to 10 volt, right? 0 to 10 volt. So solve that. The voltage across this whole thing will be 10 volt. Okay, voltage across this thing will be actually 10 volt. This will be 10 volt. Okay. That means what I can write, you know, what I can write is this IG into RG plus R is equal to okay. This is the thing. So whenever there is range given, whenever there is a range given in case of ammeter, the main current, okay, which is entering into the galvanometer and this some combination, that main current is actually the maximum range of the ammeter. Yeah, in this case, maximum range of the voltmeter will be the voltage across the whole combination. The very high resistance in series with the galvanometer then gets converted to voltmeter. Okay, the voltage across these two resistors, okay, in combination, okay, that will be the maximum range of the. So you know what is RG, you know what is RG, so then you can find out what is R. Okay, what is R? You can find out easily. So let us find out R. So this is 10 volt. Anyway, this is IG divided by this IG will be there, and this will be minus IG. Okay, I just go to the next slide and maybe press the do that. So R will be, yeah, it was 10 volt minus R G, and here will be I. Okay, this is the equation from here. IG into R plus RG instead of 10 volt. From here, so then it will be it will be. So this is 10 volt, and this is 2.5 ampere milliampere. So minus 6, this is RG is 12 volt. Okay, 12 ohm. So ultimately you'll get the ohm because this is again. So you get, yeah. So look, I write this is 10 to the power 4, this is 10 to the power 5 divided by 25. minus 12. Okay. So see, 100 will get off from here. So this is 3 by. So you will get actually 3,800 like that. Okay. So what you get is okay. So yeah. Sorry, 988. 988. Okay. So this will be okay. So what you get is this one. 3988. So this
Sir,
much,
answer is
this much, sorry, answer is 3988. Yes. Alright. Priyadashini, Priyadashini or Deepa, who were speaking. Okay. Anyway, this is the answer. Okay. This is the answer. So with this, actually, I will stop this class. So there are two types of questions from the sensitivity part and from the conversion part. I have one more problem, but I don't have time now. So we are already actually this 7th class. So I'll just send out these questions to Guna madam to our WhatsApp. Maybe they she will circulate these questions to you people, and then you people can practice those things again at the home. Alright. So with this, actually, we end this chapter. Okay. With this will end this chapter, fourth chapter. Well, next day, that means on the Sunday, we'll start a new chapter, the fifth chapter, magnetism in matter. Okay. So for today, so that's all. All right then, I'll stop it here. If you people have any question, you can ask me. Otherwise, maybe in the next class, also you can ask the question. You have something on this particular chapter. All right, Tejaswini, Deepa, see you both on Sunday.